In this last video, we will discuss on one example. This is taken from previous the past year exam. Okay, so as well, we will only consider or will only analyze the common emitter configuration circuit. Okay, so for the this question, this is common emitter with the bypass capacitor. The question is how determine the high cutoff frequency. The beta is 100, ICQ is given, VA is infinity, so this is R naught is infinity, and then all the parasitic capacitance value are given. Okay, so when you do the analysis, so the ICQ is given, you need to calculate the GM. So the GM is IC over 26 milli, so this is 0.97 milli over 26 milli. This is equal to 36.3 millisiemens. And then next from the GM, you can calculate the R pi. R pi is beta over GM. This is 100 over 57.3 milli. This is equal to 0.68 kilo ohm. So we have the GM and R pi. Okay. So and then when you want to proceed with the calculation of high cutoff frequency, this is common emitter. So we will expect a feedback capacitance that need to be transformed using the Miller theorem. In the Miller theorem, you need to have the AV. Okay. Again, so let's draw the mid-band equivalent circuit. So mid-band equivalent circuit, this is the VS, and then this is RS, and then I can combine the R1 and R2. R1 parallel with the R2, and then here we have the R pi connected to the ground because we have the bypass at the emitter. And then at the collector, we have the current source. At collector, we have the current source. And then at the collector is connected to the RC and RL. So the VI is equal to the V pi. So this is VI is equal to V pi, and then the V out is equal to, this is GM V pi. So the current towards here is minus GM V pi. So V out is equal to minus GM V pi times RC parallel with RL. So from this analysis, we will get the AV is equal to minus GM V pi RC parallel with the RL over input is V pi. Yeah. So you can insert a calculation. The GM is 37, okay, 37.3 milli, and then the RC is 5K, RL is 5K. So the AV value we will get a minus 93.25. So you get the AV. Okay. Once you get the value of AV, you can transform the feedback capacitance. So we have for the common emitter with the bypass and common emitter analysis, the feedback capacitance is the CBC. So the CBC need to be converted to the CMI. So the CMI is equal to 1 minus AV CBC. So this is 1 minus 93.25 times CBC is equal to 2 picofarad. So this is equal to 188.5 picofarad. And then you get the CMO is AV minus 1 over AB. This is CBC. So the calculation, AV is minus 93.25 minus 1, and then this is minus 93.25. 2 picofarad is equal to 2.02 picofarad. Okay. So now the CBC is replaced by the CMI and CMO. So you draw the mid equivalent circuit, equivalent circuit at the high frequency. So equivalent circuit at high frequency is you can from base, you can start from the mid band equivalent circuit, and then you can add the capacitance. Okay. So in the input side of the mid band equivalent circuit, we have the VS, and then we have the RS, we have the R1 parallel with the R2, and then we also have the R pi. Okay, now we add the capacitance. At the input side, we have the CWI, wiring input, and then we also have the base emitter, CBE, and then lastly we have our Miller cap input. This is a CMI. Okay, so we complete the input side. At the output side, first we draw the one that exists in the mid band. So this is RC, and then we have RL. Okay, after that we can add the capacitance. So in the capacitance we have the CWO, we also have the CCE, and then lastly we have the CMO. Okay, this is the equivalent circuit at high cutoff frequency. Say high frequency, sorry, not cutoff. Okay. Next we do the analysis to get the high cutoff frequency. Okay. From the high frequency equivalent circuit, you can calculate the total capacitance at the input side. The total capacitance at the input side is the CWI plus CBE plus the CMI. So this is equal to 3 picofarad plus 100 picofarad plus the CMI is 188.5 picofarad. So this is total is 291.5 picofarad. Okay, and also for the resistance at the input side, the Thevenin resistance at the input side is the RS parallel with R1 parallel with R2 parallel with R pi. Okay, so RS is 1K, and then R2 is 20K, R3 is 10K. So R2, so R1 and R2 is R1 is 20K, R2 is 10K, R pi is 2.68K. Okay, so you do the calculation. You should get 656.8 ohm. Okay, now you get the total capacitance at the input side and the total resistance at the input side. The FHI will become 1 over 2 pi RTHI CI. So this is 1 over 2 pi R is, and then this is 291.5 pico. This question will give you the value of 0.83 megahertz. Okay, this is the input side. At the output side, you repeat the same procedure. First, the total capacitance at the output is CWO plus CE plus CMO. So CWO, this is 5 pico plus 2 pico plus 2.02 pico, equal to 9.02. Okay, for the RTHO is the RC parallel with RL. So this is 5K parallel with 5K equal to 2.5K. So now you get the FHO is 1 over 2 pi, RTHO is 2.5K, and then we have this one is 9.02 pico. Okay, this calculation will give you 7.1 megahertz. Okay, you have two value, FHI and FHO. So which one will become your dominant high cutoff frequency? The answer is the lowest. So the dominant, okay, the dominant FH is 0.83 megahertz. So this is the final answer.